Bismillahir Rahmanir Rahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this particular video I'm going to discuss a few past paper questions for vectors P3 A-level Maths Cambridge 9709, and particularly we are doing some old syllabus P1 vector questions. As you are aware that after the major syllabus changes in A-level maths in the year 2020, this topic vectors is now completely tested in P3 and is removed from P1 completely. Okay, and in my online classes, I have discussed the vectors content up till the scalar product. Okay, all the basic concepts for vectors in 3D have been discussed, and now we are in a position to discuss some past paper questions of P1 old syllabus. Okay, and for the purpose of recording those particular questions which I recently discussed with my students in my online classes, I want to make some videos in English for past paper practice for my YouTube channel. So I'm discussing some old syllabus vector questions of P1 which are still relevant for P3. Okay, so first of all, we have this question, which is handout question number 2. This is October-November 2006, paper 1, question number 4. So the question is saying that the position vectors of points A and B are, you have these two vectors in 3D. One is -363 and the other one is -124. So first vector is OA and the second vector is OB, okay, respectively. So requirement of part 1 is to calculate angle AOB. All right, so what we are going to do, we are going to use the formula for the scalar product. Okay, so OA dot OB is equals to OA vector magnitude multiplied by OB vector's magnitude multiplied by cos theta, where theta is basically the angle between the two vectors. I hope you have covered this basic concept of scalar product in order to find the angle between the two vectors. What you need to make sure is that, you need to take care of a particular sequence. Either the two vectors are moving away from point O, okay, this means that the vectors are diverging from point O, okay, or alternatively, you can do it like this, that they are converging up to point O. Okay, you need to take care of this particular sequence over here. Okay, either they are moving away from point O or they are going up till point O. Okay, especially when you are dealing with the vectors in these alphabets form. Okay, so you need to take a special care of this thing. All right, so OA dot OB is equals to the magnitude of vector OA multiplied by the magnitude of vector OB multiplied by cos theta. Okay, so OA vector is given to you, OB vector is given to you. So first you find the scalar product. Okay, and then you have the magnitude of vector OA and the magnitude of vector OB. They will be multiplied together and then it will be multiplied with cos theta. Okay, so in order to find the magnitude, simply under root of a square of x component plus square of y component plus a square of z component. Okay, so basically when you have vectors in 3D, so the magnitude of the vector is under root of x square plus y square plus z square. And in order to find the scalar product, so I components will be multiplied together plus j components will be multiplied together plus k components will be multiplied together. So if you have a vector small a, which is, let's say, a1, a2, a3, and vector b is b1, b2, b3. So in order to find the scalar product a dot b, the I components will be multiplied together. So a1, b1 plus the j components will be multiplied together, a2, b2, and then plus the k components will be multiplied together. So plus a3 times b3. So in this way, you find the value of the scalar product. Okay, so I hope you have covered this in the basic concepts before attempting past paper questions. Okay, so here is basically the idea behind this. And so when minus 3 is multiplied by minus 1, so this is 3, and then 6 times 2 is 12, and then 3 times 4 is also 12. So these three values are added together. So the value of scalar product is positive. Okay. And then the magnitude of OA is under root 54, and the magnitude of OB is under root of 21. So I've rearranged this formula over here in order to make cos theta the subject of the equation. Okay. So cos theta will be equal to 27 divided by 3 root 6 times root 21. So the simplified third form of root 54 is 3 root 6. Okay, it's not compulsory to write the simplified third form. Even you can use this under root 54 as well. That's perfectly fine. So theta is equals to cos inverse this complete value. And since we have a positive value of cos theta, okay, since the scalar product is positive, so theta will be acute. So first we write the theta angle correct to a higher degree of accuracy. Okay, and then according to the by default requirement, when you are giving your angle in degrees, okay, so correct to 1 dp. So the value of angle in degrees when you are finding on exact value, okay, so you write your answer correct to 1 dp, which is the by default requirement. So therefore our answer is theta is equal to 36.7 degrees correct to 1 dp. So here was the requirement of part 1. So now let's move on to part 2. So in part 2, it says that the point C is such that AC is equals to 3 times of AB, and the requirement is to find the unit vector in the direction of OC. Okay, so for part 2, here we have the working on the next page. So first of all, we have AC is equals to 3 times of AB. Okay, first of all, we are going to find the OC vector. Okay, and for that purpose, we are going to use the vector subtraction law. So as per the vector subtraction law, we can say that AC is equals to OC minus OA, and in place of AB, we will have OB minus OA. This vector subtraction law you are studying since O-level mathematics, O-level and IGCSE mathematics. Okay, so we are going to use this equation in order to make OC the subject over here. So OC will be equals to 3 times of OB minus 3 times of OA plus OA. And then this will be simplified as OC is equals to 3 times of OB minus 2 times of OA. And now we are going to use the OB and OA vectors respectively, which are given to us in the question. So here I'm going to simplify the I, J, and K component respectively. So I component will be minus 3 plus 6, J component will be 6 minus 12, and K component will be 12 minus 6. So OC vector is 3 minus 6, 6, or you can say 3i minus 6j plus 6k. All right, and now we are going to find the magnitude of the OC vector. Okay, so the magnitude of OC vector will be under root of 3 square plus minus 6 squared plus 6 squared. So the magnitude of OC vector is under root of 81. So it is equals to 9 units. Okay, and now we want to find the unit vector in the path of OC, meaning the vector which has a magnitude of 1 unit. So as you know, the formula for finding this vector would be OC hat, meaning we have a hat above OC. OC पे hat बना देंगे. So OC hat, this will be equals to OC vector is divided by the magnitude of OC vector. Or you can say OC vector hat, this is equals to 1 upon the magnitude of OC vector multiplied by OC vector itself. Okay, so basically 1 upon the magnitude of OC vector multiplied by the OC vector itself. So I can say that I component is 3 over 9, J component is minus 6 over 9, and K component is 6 over 9. And now I can simplify the terms and I can write my answer in terms of I, J, and K. So I component is 1 over 3, J component is minus 2 over 3, and K component is 2 over 3. Either you can express your answer in this form, or you can simply say that 1/3 is taken as a constant term outside, and this is completely multiplied by I minus 2j plus 2k. It's not a compulsion to write your answer in IJK format in this particular question, but it is good. It is a good practice to do so. Otherwise, you can leave your answer in the column vector as well, because particularly IJK form is not required over here. Okay, so this was basically the question, and here was the complete answer of this question. Okay, so here was the complete solution of this question. Okay, October, November 2006, P1 question number 4. So now let's move on to the next question. Okay, up next we have handout question number 3, which is May, June 2007, paper 1, question number 9. Okay, so it says that we have two vectors, we have two position vectors over here of points A and B. OA vector is 4, 1, minus 2, and OB vector is 3, 2, minus 4. So the information given to us in part 1 is that given that C is the point such that AC is equal to twice of AB. Okay, and the requirement again over here is that find the unit vector in the direction of OC. So as it is, as we, solved the part 2 of the previous question, exactly in the same way we are going to attempt the part 1 of this particular question. So first of all, we have AC is equal to 2 times of AB. So in the very first step, I'm going to use the subtraction law of vectors. So AC is OC minus OA. This is equal to 2 times of OB minus OA. Okay, so this vector AB is broken like this, OB minus OA, according to vector subtraction law. Okay, so now we are going to use this equation in order to make, OC the subject over here, because first we want to find the OC vector. So OC vector is equals to 2 times of OB minus 2 times of OA and then plus OA. And this will be simplified as OC is equals to 2 times of OB minus OA. So we are going to use these two vectors over here, okay, OB and OA respectively, and therefore we can achieve the OC vector. Okay, the I component will be 6 minus 4, J component would be 4 minus 1, and K component would be minus 8 plus 2. So 2, 3, and minus 6. Okay, 2, 3, minus 6. Here we have the OC vector. All right, and now as you already know the fact that in order to find the unit vector of OC, so OC hat is equals to OC vector is divided by the magnitude of OC vector. So first of all, we need the magnitude of OC vector. Okay, so under root of 2 squared plus 3 squared plus minus 6 squared. So the magnitude is under root 49, which is equals to 7 units. Okay, and now OC vector hat, this will be equals to 1 upon the magnitude of OC vector multiplied by the OC vector itself. Therefore, the OC vector is 2 over 7 is the I component, 3 over 7 is the J component, and minus 6 over 7 is the K component. This is basically the vector which is having a magnitude of 1. If you just find the magnitude of this vector, this will be equals to 1. Okay, the concept behind is that, when you have OC vector like this, let's say this point is O, this point is C. So basically the vector which is having a length of 1 unit in the path of OC, this is basically the vector which we have found, OC hat, which is basically called the unit vector of OC. Okay, so this was the requirement of part 1. So now let's move on to part 2. In part 2, we have some information that the position vector of the point D is given by OD is equals to 1, 4, K, where K is basically a constant, which is unknown. And it is given that OD is equals to M times of OA plus N times of OB, where M and N are constants. So we need to find the values of M, N, and K. Okay, so very simple. Okay, so we are going to use this equation. So for that purpose, I brought the picture of the question on the next page. So OD is 14K. Okay, so 14K is equals to M into OA vector, and the OA vector is given to us 4, 1, minus 2, and then plus N into OB. So N is multiplied by 3, 2, minus 4. Okay, as we have the OB vector over here. So basically we have, an equation. Okay, so basically the vector OD is exactly equals to M times OA plus N times of OB. So we have to deal it like an equation, this vector and this vector would be equal to each other. Okay, so here is the very basic concept behind this. So I component is 1 and I component is 4m plus 3n. So 4m plus 3n is equals to 1. Okay, in the same way, j component is 4 and the j component is m plus 2n. So m plus 2n is equals to 4. So what we can do is that we can solve these two linear equations in terms of m and n and solve them simultaneously in order to find the values of m and n respectively. So m is equals to 4 minus 2n. I'm going to substitute this into equation number 1 in order to eliminate m, and I would be able to get the value of n, which is equals to 3. Okay, so n is equals to 3 over here. And since m is equals to 4 minus 2n, so m is equals to 4 minus 2 times 3. So the value of m is equals to minus 2. And now we have the k component. Okay, so basically the k component is itself k over here. So k is basically equals to minus 2m minus 4n. Okay, so k is equals to minus 2 times minus 2 minus 4 times 3. Okay, so k is equals to 4 minus 12. Therefore, the value of k is minus 8. So in this way, we have found the values of m, n, and k. Okay, so this was a solution of this complete question. So now let's move on to the next one. So up next, we have handout question number 4, which is October-November 2007, paper 1, question number 10. Okay, and these type of questions do still come in P3. Okay, where we have shapes in 3D. So here we have a cube. Okay, so the question says that the diagram show the cube OABCDEFG in which the length of each side is 4 units, and then it says that the unit vectors I, J, and K are parallel to OA, OC, and OD respectively. Okay, I is basically parallel to OA, J is parallel to OC, and K is parallel to OD. And then it says that the midpoints of OA and DG are P and Q respectively. Okay, the midpoint of OA is P, the midpoint of DG is Q. All right, and R is the center of the square face ABFE. Okay, so ABFE is basically a square face, and R is basically the center of this face. Okay, so here we have the complete information. And then in part 1, it is required to express each of the vectors PR and PQ in terms of I, J, and K. So first thing first, we want to find the vector PR. So according to vector subtraction law, PR is equals to OR minus OP. Okay, so first I'm going to find the vector OR. So now in order to come from point O to point R, okay, first you need to come like this from O to A, then A to this point, which is just beneath R, and then up till R. This is basically the path which we are looking for in order to move from O to R. So assume that this particular point over here, which is underneath R, this point is known as, let's say, X. Okay, and since this point R is basically at the center of this square face ABFE, okay, so obviously, since the cube has the length 4 units, each side has a length of 4 units, so this AX length would be half of 4, which is 2 units. Okay, this makes sense. And since R is basically at the center of this square face ABFE, so basically the length of this XR would also be equals to 2, which is also the half of 4. Okay, so obviously in order to come from point O till point R, in I component we have 4 units, in J component we have 2 units, and in K component we have 2 units. Okay, so you just need to use your observation over here. Okay, so I can simply say that this OR vector is 4, 2, 2, meaning 4i plus 2j plus 2k. And then we subtract the OP vector. Okay, so in order to come from point O to point P, we just need to travel half of the distance of OA, since P is the midpoint of OA, and since the length of OA is 4 units, so the length of OP is 2 units. So when you are traveling from O to P, you are only traveling in the I direction. So J component is also 0 and K component is also 0. So we can simply say that, this OP vector is 2, 0, 0, which means 2I. All right, so we are going to use the vector subtraction law. PR is equals to OR minus OP. So PR is basically 2, 2, 2, which means 2I plus 2J plus 2K. So PR vector is 2I plus 2J plus 2K. And now in the same way, we are going to find the PQ vector. So the vector subtraction law, PQ is equals to OQ minus OP. Okay, so first you observe OQ. Okay, so now in order to move from point O to point Q, in the K path, you will go 4 units since the cube has the length 4 units. Okay, each side is equal. And then in the J path, you are just going to cover 2 units. Okay, because Q is essentially the midpoint of DG as per the information of the question. So, this distance TQ is 2 units. Okay, and in I path, you are not traveling anywhere. In order to come from point O to point Q, in I path, you are not traveling anywhere. You are just traveling in K path and J path. Okay, so I component is obviously 0 when you are considering the OQ vector. So I component is 0, J component is 2, and K component is 4. And then we need to find the OP vector, which we already know that OP vector is 2, 0, 0, which is simply 2I. Okay, so PQ vector is minus 2, 2, and 4. Okay, it's not a compulsion to do the working in IJK form, but since the IJK form is required over here, so I've expressed my answer in terms of IJ and K. Otherwise, you can do the working in the column vectors as well. Okay, so basically, PQ vector is minus 2I plus 2J plus 4K. So in this way, we have found the PR and PQ vectors respectively in part 1. All right. So now let's move on to part 2. The requirement of part 2 is to use a scalar product to find the angle QPR. Okay, so QPR, so basically the idea behind this is that in part 1 you have found the PQ vector and the PR vector respectively. So you can use this sequence. Okay, both vectors are moving away from point P. Okay, so which means that the vectors are diverging from point P. Okay, so you need to remember that sequence. So here I've just made a very simple sketch for that purpose. Q, P, and R, these 3 points. And in part 1, we have found PQ and PR respectively. So I'm going to use the formula for the scalar product. PQ dot PR is equals to PQ vector magnitude multiplied by PR vector magnitude multiplied by cos QPR. Okay, so I've mentioned the vectors over here according to the vectors which I found in part 1. So first PQ vector, which is minus 2, 2, 4, and PR vector is 2, 2, 2. Okay, and the magnitude of the vector PQ would be under root of minus 2 squared plus 2 squared plus 4 squared, and this will be multiplied by the magnitude of the vector PR, which is under root of 2 square plus 2 square plus 2 square multiplied by cos QPR, where QPR is basically the angle between the two vectors which we need to find. So I'll continue my working on the next page. So cos QPR is equals to, I component is multiplied together, so minus 2 times 2 is minus 4, and then J component multiplied together, 2 times 2 is 4, and then K component multiplied together, 4 times 2, which is 8. And the magnitude of PQ vector is under root of 24, and the magnitude of vector PR is under root of 12. So the scalar product has a positive value, which is 8. So QPR is equals to cos inverse 8 divided by root 24 times root 12. Just put this thing in your calculator. So QPR is equals to 61.874 degrees, and correct to 1 dp 61.9 degrees. Okay, this was the requirement of part 2. All right. Then we have part 3, which says that find the perimeter of the triangle PQR, giving your answer correct to 1 dB. So very simple. We need to find the perimeter of this shaded region over here, this triangle. So PQ magnitude we already know, PR magnitude we already know. Okay. The magnitude of PQ and PR we have already used in part 2. So we don't need to find them again. We already know them. Now, all you need to do is that you need to find the magnitude of this vector QR, or you can say RQ as well. Okay, so it's up to you completely. So I have found the magnitude of QR. So for that purpose, first of all, I'm going to find the vector QR. Okay, as we already know the magnitude of vector PQ and PR, so I've just mentioned the magnitudes over here. And now I have found the vector QR in the same way I found PQ and PR respectively in part 1, according to the vector subtraction law. Okay, so QR will be equals to OR minus OQ. Okay, so OR we already know from part 1. OR was 422. Okay, so OR is 422 and OQ was, the I component was 0, J component was 2, K component was 4. So I've used these two vectors over here. Okay, so QR vector is 4, 0, minus 2. And then I'm going to find the magnitude of QR vector, which is under root of 4 squared plus 0 squared plus minus 2 whole squared, which is under root of 20 units. Okay, so in order to find the perimeter of the triangle PQR, under root 20 plus under root 12 plus under root of 24. So first of all, I'm going to write my answer correct to a higher degree of accuracy, which is 12.8352, and then correct to 1 dp according to the requirement of the question, 12.8 units. This is the parameter which we are looking for. Okay, so for the purpose of this recording, for the sake of this recording, I've discussed these 3 possible questions of old syllabus P1 vectors, which is still used for the content of P3 vectors. So inshallah, I'll see you in my next video. Stay tuned to my channel. I'll be uploading more possible questions. I'll be recording more questions for the old syllabus P1 vectors. Okay, particularly the important ones. These were quite simple. These were quite basic. Okay, so obviously we have to start with the basics and then we move up to advanced questions. Okay, so I'll be uploading the past paper questions on P3, the old syllabus P3 vector questions as well, where we use the vector equations of the line. Okay, and after the major changes syllabus of 2020, the complete vectors which is tested in P3, I'll be uploading those videos as well. So stay tuned to my channel. Much more content is going to be uploaded soon for A-level maths, Cambridge and Excel. Thanks for watching. Assalamu alaikum.